Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 43 in our incredible new tutorial series where you're teaching your Raspberry Pi who's boss. What I'm going to need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice. No sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Sunfounder Raphael kit. Most of you guys already have your gear. If you don't, look down in the description. There is a link over to Amazon where you can get this kit. And believe me, my life and your life are going to be a whole lot easier if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. And what I'm going to show you is really a follow-on to the lessons that we did in class number 41 and class number 42. And there I showed you how to transfer data back and forth between your PC and the Raspberry Pi over the Ethernet or over the Wi-Fi using UDP. Last lesson, I showed you how to create a simple client-server relationship where the Raspberry Pi was the server and the PC was the client, but the client was just sitting there going go, 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 go. And so the client would send the command go. When the Raspberry Pi got the go command, it would go, it would measure temperature, it would measure humidity, it would create a data packet, and it would send the data packet back. And so it was sort of like go, the command was done, the data was returned, it was read, and it was sort of like go, send, return, go, send, return. It was just going in a loop like that. Well, that showed you mechanistically how a client-server relationship works. But I want to show you a little bit better one today because really, if you think about it, there's usually going to be a lot more nuance. With the setup that we had, we could do what? We could measure temperature or we could measure humidity. And so what we want to do today is we want to create a little bit more sophisticated client-server relationship and also make you just start getting more comfortable with these concepts. But what we're going to do today is on the PC side, your PC in a Python program is going to prompt you for a command. And you could have two commands. You could have temp for temperature or hum for humidity. Then it's going to get that input from the keyboard. The PC is going to send it over to the server, the Raspberry Pi, who is what? Sitting there waiting for a command. The Raspberry Pi will read the command. If the command is humidity, it's going to measure humidity. If the command is temperature, it's going to measure temperature. It's going to create its data packet and it's going to send it back. And then over on the client side, you're sitting there waiting for the response, and then you get the response back, and then you decode and unpack that data. Okay, now another concept that I want to give you, because you've got to remember, you could have more than one client asking for data, and you could have all types of things going on the server side. And so there is opportunity for various things to go wrong that you might never anticipate could go wrong. And so let's say that you're doing temperature and humidity, and let's say it's a very dry day. So you say, you send the command temperature, and then you get back the number 85. Then you send the command humidity, and you get the number back 10. Okay, and then you do that a few times, and then you ask for humidity, and you get the number back 95. What clearly has happened there, somehow, some way, between you sending the command, it doing something, it may be servicing other clients, and it's sending you data back. Somehow, you would ask for humidity, but you got temperature back. And so really a better way to configure these handshakes, these relationships between client and servers, is something that we learned way back in first grade, and that is always answer in complete sentences. So if the client says, "What is the temperature?" how should the server answer? The temperature is 95. Now, if the client says, "What is the humidity?" and then the client or the server came back and said, "The temperature is 95, you would know, oh, I might have asked for humidity, but for whatever reason I got temperature, I'll ask again or something like that. But you want to tag the data so that before you go off and make a decision based on the data you got back, you're sure that you got what you asked, because this might be like something really important. Like maybe, you know, if you got the wrong one, you would turn the sprinkler system on where already the humidity was too high. Okay, so you see, you want to make sure that you're making decisions based on good data. So you want to absolutely limit the ability for there to be any confusion or any mistakes, and that you didn't actually end up with what you asked for. Does that make sense? I hope so. Little activity back over here on the island. Okay, I always like to see a little activity back over on the island. But what we're going to do now is we are going to move over to the Raspberry Pi, to the server. And before I do that, let's just talk real quickly about our setup here. And I showed you how to do this exhaustively in lesson number 25. I have the DHT11 temperature and humidity sensor going to the breakout board hooked up to the Raspberry Pi that is not sitting perfectly straight. We got to correct that. We cannot go through a lesson with a wompy jawed Raspberry Pi. That looks much better. This looks pretty straight. I think it needs to come down just a scooch. Perfect. Perfectly square. Okay, so you can go ahead and hook this up. I give you a quick schematic. Here you can see that there's just 3 connections over there. It's very, very simple. The one thing I will show you is don't forget that 10K resistor between the center leg of the DHT11 and the power rail. Very important for you to put that 10K resistor in there. And then you can come over to like pin 27 or pin 17 on the breakout board. Either one of those is fairly convenient, but you can go ahead and hook this up. The one other thing that I should tell you, if you are jumping into this lesson and have not taken the other lessons, to use that DHT11, you do need the DHT11 library, and it does not come installed with the Raspberry Pi operating system, but you can do just a simple pip3 install DHT11, and that will pipe pip3 install DHT11. Okay, and it's going out looking for it, and for me, I already have it, and since it says already satisfied, it just goes on, but you might take, 20, 30 seconds to get that installed. And then at that point, we are ready to come up and start writing our program. And so we're going to open up the most excellent Thonny, okay, and some people call it Thony. I think I like to call it Thonny, and let me bring it down here. All right, there it is. Okay, close that assistant. Now, what are we going to start with? We're going to create the server on the Raspberry Pi. Now, a lot of this will be familiar to you from last week and the week before last, but I like to do it again along with you just so that you're getting familiar with it. So if we're going to do communication over Ethernet, we communicate over a socket. So we need to import socket. We need to import time. We're going to be talking to that DHT11 over the GPIO pin, so we need to import rp_i.gpio as GPIO. So now we can talk to those pins. Let's go ahead and set up the mode of the GPIO pin. So we'll say GPIO.set mode, and we are going to be operating with the GPIO.BCM numbering system. Why? That breakout board has labels, and it's labeled in the BCM protocol. Okay, so BCM, if you do this, it'll match the number labels on that breakout board. And now I want to go ahead and create my sensor object. And so I'm going to say my DHT is equal to little DHT11, which is the library, dot big DHT11, which is the method. And now how am I connecting to that? I am connecting through pin 27. You put whatever pin you use, but if you use 27, make sure that center leg is connected to the breakout board on pin 27 as labeled. Now let's start working on the server. So we've got to tell it how big of a buffer we want to use. So I'm going to say buffer size. Let's make it amply large. So let's make it 1024. And then I need to go ahead and set up my server IP. And that is going to be the IP of my Raspberry Pi. So I come over here ifconfig, like that, and you can see that I am on Wi-Fi operating at this IP address. Let's see if I can just grab that and then come back over here. That we need to put in single quotes, and so it is going to be like that. Okay, that's the IP address. Now I need to do a server port, and the server port we can use 2222. It doesn't matter, just make sure you're using one that's not being used, and make sure you use the same one on the client and the server. Hopefully that makes sense. Okay, so we've got our port set up. Let's go ahead and start our server. So we will say RPI server is equal to socket the library dot socket the method, and then we've got to tell it that we're doing UDP. So we've got to give it two parameters so it knows to use UDP. One is socket dot AF underscore INET, AF underscore INET, and the other one is socket dot sock underscore DGRAM, like that. I think that looks good. Okay, now what we are going to need to do is we are going to need to go ahead and bind that server to the Raspberry Pi's IP address, so that the Raspberry Pi, the server, knows that it wants to be going through its own IP address, and in effect it sort of lets it know that it is the server. So we are going to do RPI server dot bind. And what are we going to bind to? We are going to bind to a tuple. So I need to open another. I think it would be kind if I made this a little bit bigger for you guys. Let's see if I can fix that real quick here. Let's see, 24. Does that show up a little better? Yeah, I think that'll be a little easier for you to read. So I open the bind, and now I open a parenthesis for the tuple, so there's two, and I can just put in here now server IP and then comma server port, and so now it's going to know what to bind to, both the IP and the port. So now you close the tuple and then you close the bind. All right, does that look good? I think it does. And now your server is running. So I'm just going to print on this side. Server is up and running, like that. Close the print. Okay, now we are going to want to sit here and we're going to want to listen, and we're going to get a command, do something, and then we'll listen again. So this should be in a while loop, so it just sits there acting as a server. So we're going to say while true. When it's true, true is always true, so we're creating an infinite loop here. And so what do I want to do? I want to sit and wait for a command, and when I get that command, then I'm going to read it. So I'm going to read it into CMD and address. When a client sends me a command, it sends me the command and it sends me its address. So I've got to what? I've got to read the command and I've got to read the address. And then I do that at the server, RPI server, and then what's the command? RECV, like receive from, RECV from, and then how big? Buffer size. Now, how does it know where to go? How does it know where this is? Well, it knows where it is because we did this bind up here. So you see, we don't have to give it an IP address because we bound RPI server. We bound it to this connection here. Okay, so that looks good. So we receive from. Now we have a command. Now we need to decode it. So I'm going to say CMD is equal to CMD.decode, and then we are going to decode it with UTF-8, and then we're probably going to use that again. So let's just see if I can copy that. All right, so it'll be easier next time. And now I'm going to print the command, and that is just going to help me in my debugging on this side. I'm going to run it and see, just see that it's working. So that's just kind of a little print statement to help debug. Okay, so we're going to print the command. Now, what three possibilities are the command that we would get? Well, one would be that we get the command temp, which means we want to measure temperature. The second possibility, we get the command humidity, or hum, that we want to measure the humidity. And the third option is we get some other command, and that would be an invalid command. Anything other than those two would be an invalid command. So we need to deal with those three possibilities. So let's see, if CMD is equal to temp, that will be the allowed command temp, then what am I going to do? Well, what I'm going to do is I'm going to want to get the result from the DHT11. So result is equal to my DHT, my DHT dot read, like that. So I'm going to read. Now, sometimes you don't get a valid reading. So if the reading is not valid, so if valid reading is false, meaning that you didn't get a valid reading, you want to read again. And so what I'm going to do is I'm going to say while result dot is underscore valid, like that. While read underscore is valid, open close, while that's equal false. So it's false. The reading is not valid, which means the reading is not valid. And so what I'm going to do, I'm just going to put a print just so that we sort of see that that happened, that we got down here. And I'm going to say bad reading, trying again. So we know this is going to happen, so we're not going to panic. We're just going to say, oh, we got a bad reading. And then what do we want to do? We want to do another read. So we'll say result dot is underscore valid. Okay. Or no, I'm going to say result is equal to my DHT 11 dot read. So we're just going to do that read again. Now what you have to see here is that if this reading here is bad, it's going to stay in this loop. So it's going to stay in this loop until it what? Until it gets a good reading. And then once it gets a good reading, then it is going to drop down here, if that makes sense. Okay, now I've got what? I've got my result there. And so now that I have my result, I need to go ahead and start building my data string that I'm going to send back. Well, I'm going to send back the command that I just did because I thought you said temperature, so I'm going to return to you data that includes the temperature tag. So I'm going to put that tag back on just so the guy on the other end can see that he got back what he asked for. I hope that makes sense. So it's going to be command, and then I'm going to add to command a delimiter or a separator of a colon, and that way on the other side I can split on the colon again, and then I'm going to add, what? The string value of result dot temperature. So now I've got a problem up here. You see where it was green, I did not end. Doesn't count as a mistake if you catch it before you run it, okay? So now I've got my data packet put together, and that looks pretty good. And so now I need to encode it for send. So I'm going to say data is equal to data.encode, and then let's see if I actually, yeah, I'd copied that correctly, and so we encode it with the UTF-8 again. So it's encoded, and so now let's send it. So we'll see RPI server dot send to, who do we send? What do we send? We send data. Who do we send it to? Address. And who is address? Address is whoever asked for it. So whoever sent me the command also sent me his address, and then here I'm sending him the data back to that same address. That really, I think, should make a lot of sense, shouldn't it? Now we're going to do the same thing for humidity, so I'm going to live dangerously and take this whole thing and come down here and paste it. Only this time, instead of the command of temperature, we're going to have the command of humidity, and then we're going to read it. That all looks good. That all looks good. Here, though, instead of result.temperature, we are going to send back result.humidity. I think think that's the only thing that I need to change there. And now finally, I need to do that third case, which is if I got something that I don't know, or I got an invalid command. So I'm going to say, what are the invalid commands? Well, if CMD is not equal to humidity and CMD is not equal to temp, what have you got? You got yourself an invalid request, and we're going to sternly warn him about that. Now we won't be too stern, but we will let the user know that that was not valid. And so what we're going to do is we're going to say data is equal to CMD. So that command he sent us, we're sending it right back to him. And then what are we going to send with that? Plus the delimiter again, like that. And then what are we going to send? I'm just going to send the string null. And anytime the client gets the null response back, he knows that he sent something that I did not know what to do with. So does that make sense? Okay, so we're going to have that. And now we're going to data is equal to data.encode. And we're going to see if I can still do that. No. I messed up bad there. I messed up bad. I forgot that I'd copied all that code. That was a terrible mistake. If you live with copying and pasting, you're going to die with copying and pasting. Okay, now what we're going to do is we're going to send that back to him. RPI server dot send to. What are we going to send that data, and who are we going to send it to? Address, like that. Okay, guys, how many mistakes have I made along in here that I didn't see? Okay, so we're going to go ahead and run this now, just to find any gross errors that I made. Humidity, what is that nonsense? Okay, it didn't like my hum. Okay, and that's in line 26. If command equal hum, maybe I've got an indentation. Yeah, okay. You see, when I pasted, I didn't get the indentation right, so I take everything out and tab over. I told you if you live by the copy and paste, you die by the copy and paste. DHT11 not defined. What is that nonsense? That is in line 6. Okay, my DHT is equal to, oh, I did not import DHT. That is terrible. Okay, so up here I needed to import the library DHT11. So that makes sense. Let's run this. You guys get to see a little bit of real life. Okay, server port, I can see that I made the O wrong there. So that is in line 13 here. That was a large O and it needs to be a little o. Okay, and now what it says is, I can see that you guys, unfortunately, we're not seeing all of that, but I can see here that it says server is up and running. So at least I got rid of kind of the gross errors there. So our server is up and running, and so we need to move on over here to, we are moving on over here to the PC. Have a little sip of my jet fuel. And I need to switch keyboards, so I get my keyboard PC. And this is actually going to go pretty fast because the server side, I mean the client side, is really a lot easier than the server side. And so what we are going to need to do here is, okay, so we are going to need to import the socket again. We are going to need to import time again. I'm going to go ahead and set up the server address. Now guys, this is something that a lot of people get confused about, like, because on the server side, you put in your own IP address, the server IP address. And so what people sometimes do is they come over to the client and they put the client's address. No, on the client side, you also put in the IP address of the server. Okay, it's just you've got to not try to change that, and it's a little bit confusing to people. So I put in the server's address 192.168.88.41. Pro tip: You use your server's IP address. Don't use my server IP address. All right, you use your Raspberry Pi's address. So I have that, and then I created a tuple there with that open parenthesis. So I'm going to go ahead and put in here the port number, which is 2222, and this needs to match whatever we did on the other side. Now also we need to tell it the buffer size, and this needs to match 2, and that's going to be 1024, like that. That looks good. Now let's create our client. UDP client is equal to socket the library dot socket the method, and then again those same things, socket dot af underscore init, and that tells it that we're doing UDP, and the other parameter to tell it UDP is sock underscore DGRAM, like that. Okay, so now we have created our client, and that looks pretty good. Socket.socket, that looks pretty good. Now we need to go out and get ready for a command. So again, we're going to put this in a loop, while true when is true, true, true is always true. So we created an input loop. Now we're going to get the command now from the user. So I'm going to say command is equal to keyboard input. So I put input. What is the prompt? The prompt is, what is your command? And then like that, what is your command? Is it as simple as that? Let's see, I think it is as simple as that. Oh, no, I know what I need to do. I need to give it its choices, okay? Because right here you could do a whole lot of error checking, but we're just going to assume that the user is adept enough to enter the choices that he is given. So we're not idiot proofing it, if you will. Okay, so now we need to, we've got the command. Now what do we need to do? We need to encode it. So CMD is equal to cmd.encode. We got to encode it for sending, and then we'll do it with UTF-8, again, close and close. And then I think I will copy that just for fun. Now we've got the command. The command is encoded, and so what do we want to do? We want to send to. So I'm going to do UDP client dot send to. Okay, UDP client dot send to. What am I going to send? The CMD. And then who am I going to send it to? The server address. Now why do we have to put that in? Because there could be 10 servers, and we got to tell it which one do we want to send it to. Server address, which we set up here. So we're going to send the command to server address. Now once we do that, what do we need to do? We need to now listen for the response to come back. And so with that, we'll do a UDP, okay, a UDP no, I've got to read it into something. So now I'm going to get data back, and then I'm going to get address back. So I'm going to get data and address, two things back, and that's going to be UDP client dot receive RECV from, and then just buffer size. Okay, and then where is it going to be listening to? Well, whoever it sent the data to, it is going to be listening for the data to come back from there. And so this server address on the send is what clues it in as far as what to listen to on the way back. This address here is the address that it gets coming back from the server. It doesn't have anything to do with where you're sending. It's a value that you're reading. Hopefully this is starting to make a little bit of sense now. Okay, so now we have the data, and so we've got a data is equal to data.decode, and then I got that from copying a while ago. And now what I want to do is I want to say my data array, I want to take that's like a command, a colon, and a number, and I want to split data. So I'm going to say data.split, and where do I split it? I split it at the character colon, and so now I should have an array with two elements. the command in the first element and the value in the second element. Okay? I'm just looking, making sure that this is making sense. I think it does. Now there are three possibilities. If data array, the 0th element, if that is equal to temp, then what do I do? Well, I print temperature, and then what? Data array 1. Now understand that this is going to be a string, but we're not doing any calculation on it. It's not going to be the number 75, it's going to be the string 75, and that's okay. It's just if you're going to do some math on it, make sure that you convert it to a float. Okay, so that is going to give me the temperature. Now, almost the same thing. If data array of 0 is equal to humidity, then print humidity, and then what? Data array, same thing, 1. Because if it gets here to this point because of the if statement, that number will be what? The humidity. I got to close that. I didn't close the parenthesis. Okay, so then what is the other possibility? If data array of 0 is not equal to humidity and data array, I better get that where it doesn't go behind my head. And data array of 0 is not equal to what? Temp. If it's not one of those two things, it's what? It's invalid. Okay? And then what I'm going to do is print invalid response. And then what I'll do is I'll go ahead and print data array 1, which just should say null there, just to kind of confirm that the world is operating as I expect. Okay, over on the other side, we had left the server running. I do believe on the other side we had left the server running. So let me see here. I just need to make sure that you can see this all the way. I hate this thing where it pops it to full screen even when you don't want it to. Okay, I think that you can see that pretty well. I hate it when it does what it just did. I'm not going to fine-tune it too much this time, because when I fine-tune it, what happens? It goes and it pops at full window. Okay, let's run it and see if we can find our errors. So we're going to say run module. Okay, it's going to save it, and then I'll just say cs2.py like that. Okay. Look at that. At least we got a. I missed. I can't do it with that missing parentheses. Let's go ahead and fix that. So right here, I'll put a temperature humidity. Okay. So now let's run it again. It's kind of encouraging I didn't get a gross error anyway. Okay, let's say TEMP like that. Okay, so now I'm not getting a response back. The first thing I'm going to do is I'm going to come over here and I'm going to make sure that I've got that server running on the Raspberry Pi side. So let's stop things, make sure it's stopped, make sure it's running. Okay, now let's come back over here. Let's kill this. Okay, I killed it. Let's try running it again over here, run module. Okay, so I'm going to say temp. Okay, and it's hung again. So the question is, what did I leave out? So let's make sure. So I said I got temp or humidity. That's good. I encoded it. I sent it. And then when I sent, I didn't get anything back. And so let's go over to the side over here. I'm also 192, 168, 88, 41. That looks good. Over here. So I have found my error. It is over on the server side. I created my DHT as the object, but then when I called the object, I called it as my DHT 11, right like that. And so right there is where I got the problem. And then I copied and pasted, so I better come down here and I better fix it there. And then up here, I did get it right. I hope probably a lot of you guys found me, saw that I'd done that. And so I will try this again. Okay, so I'll try this again. I will come over here, I will run, and then it says server is up and running down here. Server is up and running. Let me show you. I'm sorry that title is kind of in the way, but you can see server is up and running. And so that makes us happy. And then we're going to come back over to the client side. Okay, and now I will run that. And same thing, I want to get this where you can see it. Okay, so what do I want? I want temp. And then when I say temp, shazam, look at that. 26.2 temperature, humidity. Let's try temp again. Giddy up, 26.3. My excitement radiated a little bit of heat that was detected by the DHT 11. Let's try humidity. Boom, 65% humidity. That sounds right. Temp. And now let's see our error checking. Let's see if I ask for pressure and then it comes back. Invalid response, null, and then I can go back to temp. Boom, that works. Okay, I'm going to try one other thing here real quick. I want to see if this is robust, and so I want to see that if I just keep hammering this thing, if it keeps working. So I'm going to take this, I'm going to comment that out, and then what I'm just going to do here, I'm just going to say that CMD is equal to temp, like that. And then down at the bottom, just so that I'm not like going too crazy fast, I will put a time.sleep of 0.1, just something like that. But I want it to go fast, but I don't want to kill it. So let's just go run. Okay. Okay, there it goes. So let's just let that run a second and see if this thing looks pretty rugged. Now, in reality, when I'm setting up something like this, I would like to let it run for 2 or 3 days. Okay, I would like to let it run for 2 or 3 days to really make sure that there's not some unusual condition that would cause me to lose that socket. But this is looking really, really good. The thing is just whirring on by. Okay, guys, I hope I haven't bothered you. Man, it's been like 5 lessons, right? We learned how to SSH into our Raspberry Pi with PuTTY so that we could have a remote terminal window and make the Raspberry Pi do whatever we wanted through the terminal window. Then we learned how to use VNC for you guys that are a little bit more comfortable, VNC for you guys that are a little bit more comfortable with a graphic user interface. I will be honest with you, I really don't like using VNC. I can do pretty much whatever I want from the command line. So I usually, if I'm going to do things that way, we'll just use PuTTY to SSH in. And then 3 lessons ago, I showed you how to just do a simple connection over UDP. Then last week I showed you a simple client server. And then today I showed you a little bit more robust method of creating a client server where you're a little bit more deliberate in making sure that you are getting the data that you think you need. Or make sure that you got the data that you were asking for. Okay, guys, what's coming up next, I think, is I actually want to go in, and on our next lesson, I think that I am going to want to show you how to use the Raspberry Pi camera from your kit on the, Raspberry Pi. And so what would be great is, and I think I mentioned this last week, but really the only way that I know how to make it do what I want it to do is for us to be on the Buster operating system. And so it would be great if you guys now, preparing for next week, went ahead and flashed an SD card for the Buster operating system. So whatever the full graphical interface, not the light version, but just the full version of Buster on a SD card, then next week I'll show you how to install OpenCV, how to get GStreamer working, and my goal in next week's lesson is to just have a video window that pops up and shows you the video coming from the Raspberry Pi camera. And so that's kind of what my goal is for next week. Next week might be a little bit of a long lesson because we've got to install several different libraries and so forth, and the actual code that we'll write will probably just be like 8-10 lines, and so the code will be easy, but we just got to go through a process to get your Raspberry Pi configured like mine is, so that when we try to do this, the stuff on the lessons going forward will work properly. And I will say, I will let you know that we're going to do quite a bit of lessons on the camera, because there are just so many things that you can do, so many exciting things you can do when you add a camera to your project. Okay, guys, I hope you are enjoying taking these classes as much as I'm enjoying making them. If you're enjoying them, be sure to give us a thumbs up. Also, it's a really big help for us if you leave a comment down below. That helps us with the old YouTube juice. Subscribe to the channel if you haven't already, and most importantly, share this video with other people, because the world needs more people doing engineering and coding, and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.